We are live.
Hello, everybody, and welcome to the 11th of our monthly series of virtual astronomical outreach events, brought to you in a collaboration between the Riverside Astronomical Society and the Department of Physics and Astronomy at the University of California in Riverside. My name is John Liederbach-Vega, and I'm the Outreach Director for the Riverside Astronomical Society, and I'm coming to you from my home in Riverside. Zanan?
Yes, well, thank you, John. Hello, everyone. Welcome, depending on where you are on the globe. Good morning, afternoon, or evening. I know we have a worldwide audience, so welcome. My name is Nandu, and I lead education and public outreach in the Department of Physics and Astronomy at UCR. I am a professional astronomer, so are many of the graduate students here. And we are very excited to see you here tonight with us. So I know some of you might have been with us for a little while. Some of you might be just checking us out for the first time. Regardless, we hope you have a good time.
So tonight we have a theme. Every month we try and have a theme to kind of guide us through our presentation. And tonight our theme is the constellation of Sagittarius, which for many people it is their favorite constellation because it's full of so many beautiful things to explore. Some people might be their second favorite because some people actually like Orion better. But anyway, it is, as you may have heard before, there's in the constellation in the Messier list, list of 110 different beautiful deep sky objects. The Sagittarius constellation has a total of 15 of them. So we're not even going to be able to really scratch the surface or not do anything more other than scratch the surface of all the beautiful things in Sagittarius. Let me do a quick share just to show you, in case you've forgotten, or maybe this is new to you, what are we talking about when we're talking about Sagittarius? What is this that we're looking at? And so right in the middle of your screen, you should see this thing that looks pretty much like a teapot. There's the base, the body of the pot. Here's the handle of the pot over here. Here's the spout, and here's the lid. And there's all this steam coming out of the spout that you can see there, which is the Milky Way. Now, indeed, pretty much everything we see in the sky is the Milky Way, but tonight we're focusing on this particular area of the sky, Sagittarius, and the steam there is kind of looking towards the center of the Milky Way. And as always, if you can watch us on a big screen like a tablet or a desktop PC or a television, you're going to enjoy this more because we're going to have some pretty spectacular objects to show you, but they won't look very spectacular on a phone, on the screen of your phone. So if you can, log on with the nice big screen, and we're going to look at 4 different areas of Sagittarius with our telescopes. So that will show us a variety of different kinds of things that are waiting for us there. Sanan?
Thanks, John. And next, I will be introducing our lovely volunteers tonight with us who will be moderating the live chat that you can see on the right-hand side of the YouTube page. So I will let them to do a quick self-introduction. First, we have Jessica.
Hey everyone, I'm Jess Stockel. I am a rising 5th year grad student at UCR studying globular clusters and galaxy formation, and I am very excited to answer all your questions tonight.
Thanks, Jess. Next, we have Garrett.
Hello everyone, my name is Garrett Lopez. I'm a rising 3rd year graduate student studying dark matter and the early universe, and I hope you enjoy the show tonight.
Thank you, Garrett. Next, we have Yongda.
Hello everyone, my name is Yongda Zhu. I'm a 4th year PhD student starting the early universe. Hope you enjoy our show tonight. Thank you.
Thanks. Franco, you're next.
Hi there, my name is Franco Iglesias. I am a 2nd year master's student at CSULA studying physics. Glad to be here with you guys. See you guys in the chat.
Thanks, Franco. And finally, we have Cheryl.
Hi, everybody. Welcome. And I am a retired school teacher, and I'll be giving a question to one of our trivia questions, answer to one of our trivia questions, and helping in the chat tonight. So good to see you.
Thanks, everyone. So the other telescope operators, we will introduce themselves when it's their turn. So as you can see in the live chat, we welcome all kinds of questions or discussions, comments, and you should feel, very free to engage in any kind of discussions with others. But given the large group that we're having, we kindly ask you to be respectful to others at all times. So most of the questions in the live chat will be answered by our chat moderators, just introduced here. And the remaining will be delivered to the panel, and we will do a live Q&A throughout this event. So if you have any questions, feel free to put them there, and we will get them answered. So this is our 11th Stargazing event, as John previously mentioned, and we're super grateful that you're here with us. So after this event, we would like to hear from you regarding how we did and how you would like us to improve so we can make this event and this program better for you. And in addition, at the end of the event, if you can stay, we will be doing a raffle. And everyone here has a chance to win. So John, you would like to say something about the raffle?
Yes, we have a book called Touring the Universe. And this is, if you want to buy this on Amazon, you can for like $35. But here you can get it for free if you win our raffle. It's about 127 pages. It's a great introduction to the science and to the hobby of astronomy. So hope you win.
Yes, good luck, everyone. Okay, so I guess without further ado, I am now turning it to John to introduce our first target of the event.
Yeah, so there's, as I mentioned earlier, in Sagittarius, there's all kinds of wonderful things to be found. And one of those types of things is one known as a globular cluster. And Randy's going to go outside with his scope and show us one. Take it away, Randy.
Very good. Let me get the screen going here. And let's see if I grab the right one. And here we go. It should be a nice little start.
We'll
okay, very good. Well, my name is Randy, and I am a long-term member of the Riverside Club and amateur astronomer. Tonight, you'll be looking at images, what is through a 8-inch telescope, which means it's a mirror 8 inches in diameter. The tube is about 10 inches wide and about 3 to 4 feet long. It's not particularly long, but it's a fast system. Anyways, M22 is an old globular cluster, but it still has some tricks that we need to learn from it. It's discovered in 1665 by a German astronomer, Abraham Ile, who was looking for Saturn at the time. M22 is 12 billion years old, but it has some interesting stuff in it. It has 6 planets that are very massive. They're objects that are not orbiting a star, but they're the size of the Earth. There's one very rare 6,000-year-old planetary nebula with a central blue star. It's kind of unusual for globular clusters. 2 massive black holes in the center, and a suspect of 5 to 100 more throughout. 83,000 of the oldest population 2 stars in our galaxy. And it has a mass of 500,000 suns. And of course, 32 variable stars for those of you who are into that type of star. As John had showed, you need to go find Sagittarius, which is usually pretty easy with Scorpio nearby, and then Sagittarius, a teapot. And he said the steam was coming out of the spout, and later in the night, as this tips over, you'll be pouring out the hot tea or water onto the scorpion's tail. So the best time is now, July and August. You look to see Sagittarius. In the east of that, you'll find, actually it's just slightly northeast of Sagittarius, the top star, Caus Borealis, and you'll find M22 right up in here. In dark skies, you can see it with the naked eye or telescope or binoculars. If you're in a mildly light polluted skies, you're going to need a pair of binoculars or telescope. If you're like I am here in Riverside, California, good old sunny Southern California with its smog, you're going to need a telescope, probably something on the neighborhood of about 6 inches or larger to really see some details with it. If you want to look through the telescope right now, this is exactly what you'd see. Because of the light pollution, you'll notice that the background isn't completely black. You can see though the globular cluster here, and it's actually taking up just about the whole picture in here. There are other stars in the background, which is part of our Milky Way. Globular clusters are usually round, spherical, or slightly oval, and they group the oldest stars of our galaxy. This one's been studied for over 356 years. It's an easy object to find and to see. It's a good amateur object, especially for first learning. It's about 10,600 light years away, and it's about almost 100 light years across from one side to the other. And if you could see all the stars with your naked eye, this would appear in the sky about the size of the full moon. But unfortunately, you won't see all the dimmer stars. You only see the central portion with your eye on a dark sky. This cluster, because of its oddities, actually brings up a lot of questions like, how do the stars interact with these black holes, the central core? Why haven't they been torn apart and turned into a big stream going around our galaxy? How is this thing stable? Because two black holes in the center are okay, but multiple usually means kind of spells disaster one way or another for the stars and for the cluster. And yet this seems to be in a very nice equilibrium. It's been that way for a long time. Where did the massive planet-sized sort of rogue planets come from? What's their origin? And of course, there's some advantages in using these black holes that are in here for lensing. They bend the light coming around them and makes it amplify the light of objects behind them. Here is part of that Milky Way. Here is our M22 right in here. And as we look there, we are looking towards, not exactly at the center of our galaxy, but looking towards it. Here we see what the typical orbits of globular clusters are like. They don't stay in the flat plane. They orbit around the center at various angles. So we're here. That means that M22 is sort of like about in this area right in here as we're looking towards the center. This is a combination photo of both infrared and optical being the Hubble telescope and infrared being the IRAS satellite. How they claim this is the planetary nebula is way above my pay grade, but I'll just take their word for it. And then this is where the two black holes were discovered to be between 10 to 20 solar masses. So they're fairly massive black holes. This is what it looks like if you look through a good sized amateur telescope. This is an amateur astronomer drew this. It's a hand-drawn picture of M22. This picture is a color photo done by a member in our club called Alison Wong. He does excellent astrophotography. You can see many of his pictures at astro.com. Sometimes I joke around and say, why don't they just pay Allison to take pictures? Because this next picture is by the Space Telescope, and it looks pretty good, but Allison's actually pretty comparable. But that's not being fair to the Hubble telescope, because this is a low resolution picture made to fit through Zoom and on the internet. So this is actually fairly low. You can get a lot more resolution on what the Hubble can do. And you can do things like zoom into it and see the stars in the core of M22. With that, I'm going to turn it back over to Zenon and John.
Thank you, Randy. That was terrific. So instead of you guys just sitting there watching us tonight, we were going to kind of get your brains working. We have some questions for you to see what you know about Sagittarius and the Milky Way. Zenon?
Yes. Well, our trivia question number one for tonight is, do you think we can directly see the center of the Milky Way with naked eye? That is a yes/no question. If you want to challenge yourself a little bit, then we have a second tier, which is, why does the Milky Way appear to be a hazy band of light in the sky? If you have ever thought about that, put it into the chat, or anything that you wanted to say about these two questions. So later, Cheryl will reveal the answers to us.
All right, so now we've already know now that that Sagittarius has globular clusters, as Randy showed us, but it also has some other things, some nebula, some clouds of wonderful things. And Brian is going to take us outside and show us some of those. Brian?
Yes, thank you, John. Let me go ahead and share my screen here. All right, so this is the Trifid Nebula. The image you see here on the left side of the screen is straight from my telescope. And by the way, I am Brian Cox, and I'm with Riverside Astronomical in the outreach team. I'm up in Oak Hills, California, which is along the 15 freeway on the way to Las Vegas. And I'm showing you the Trifid Nebula through my 120 millimeter refractor. Now, even though I'm using a telescope to show you this object, this is a great binocular object. So don't hesitate to go outside with your binoculars and take a peek. I'll show you where it is in just a moment. By the way, that's a silly name. I used to think it was Trifid, as in some kind of flower, but it's actually Trifid, meaning three lobe. Where is this located? It's actually in the steam that John mentioned. If you take a look at the teapot from the spout, follow it up, then we have a few different jewels up here in the steam, so to speak. And here's M20, the Trifid Nebula, just north, I would say, of the Lagoon Nebula, which is another wonderful object. This nebula is amazing. It just keeps on giving. Not only does it have an open cluster of stars, but it's an emission nebula. And that's the red section you see in the picture. Emission tells us that the gas itself is giving off light of its own. But it also has a reflection nebula, which is the blue section. Now it's somewhat subtle in the live image here. This is to the left. I'll show you a processed image in a moment that'll let you really see that blue. So in other words, the reflection means that it's light that's simply bouncing off this gas, which ends up being blue. And just when you think you've seen all you can see, there's more. The dark lanes that actually divide, I should say, the nebula into sections, that's considered a dark nebula and has a designation Barnard 85. Now, this object was discovered by Charles Messier way back in 1764. And as far as I know, he's the one who gave it that name, Trifid, for three lobe. Now, how far is this object? It is about 9,000 light years from Earth and about 42 light years across. Now, so far I've shown you this live image collected straight from the telescope. Let me show you now a processed image that I captured last week. So here we can see an image that I captured back on July 28th of this year. And this is a combination of an hour of 2-minute exposures and then processed in a program called Pix Insight. Now, so far we've been talking about visual light. What can we see with our own eyes or capture with the camera that we can then enjoy with our own eyes? Well, let me talk a little bit more about what we could see in the infrared. Now, in this slide, we see a collection of images. To the left would be a visible light picture captured by Kitt Peak National Observatory. These three other images are considered false color, and it was actually taken with the Spitzer infrared telescope. Now, why do we call it false color? Well, we can't see infrared, that's past red in the spectrum, so they use a computer to translate it into colors we can perceive. And what infrared allows us to do is see past the dust, which really helped us understand how remarkable a star-forming region this really is. So in other words, there are brand new stars being born as we speak within this dense cloud of gas. Now, speaking of dense gas, let's take a look at another picture. No view, I think, of an object is complete without seeing what Hubble would have to say about the situation. So here on the left, we see first an image of the Trifid Nebula from the Hubble telescope. And then we have a close-up. Now, it may not come over on your screen, but we have a little tiny green-blue area that's broken up and zoomed in by Hubble here on the right. What's going on with this? You see this lobe, and then it has two little antennae sticking out. This really fascinated scientists as soon as they started to take this closer look. This dense region, this big lobe, is considered a star-forming region. We would also call it a stellar nursery, and it's full of embryonic stars. Now, there's two so-called pillars sticking out from the top that have two different reasons on why they exist. The thin, wispy stellar jet, that's actually the skinnier of the two. That's protruding almost 3/4 of a light year out of the head of the cloud. And it's coming from a very young stellar object that's inside the cloud. We call this a stellar jet. And they're examples of exhaust gases that are a byproduct of the formation of stars. Now, how about this other stalk that's coming up somewhat to the right? This one is an example of an egg, but not the kind that comes from chickens. This is an evaporating gaseous globule. And we'll see more examples of eggs in Manny's presentation on the Eagle Nebula. So with that, I'll pass it back to you, John.
All right. So you guys have had a few minutes to think about those questions that's on asked. So let's ask Cheryl, what's the actual answer? Cheryl?
Cheryl,
Sorry about that. I forgot to unmute myself. Sorry about that. All right. So our question for the tier 1 question was, can we see directly the center of our galaxy, the Milky Way, with our naked eye? And the answer to that question is, well, no. We can only really see back about 6,000 light years in time/distance in our galaxy in that disk. And our solar system is estimated to be about 26,000 light years distance from the galactic center. So unfortunately, we just can't see back that far. But there's another reason as well. Our Milky Way has a low surface brightness. So what that basically means is it's just not a very bright thing. We need to be in a very dark sky to be able to see it. So if you're trying to look at it from a suburban area, an inner city, your sky is just not simply dark enough to be able to see it. So you're not going to be able to see the center of our galaxy either. Another thing that's involved here is that even though we have the best conditions in the world, we still have interstellar gas and dust that is blocking light from the galaxy to shine through. Something I read was estimating up to about 50% of the light we are not seeing due to the gas and dust that's in our way. So we're not being able to see that center of our galaxy. And just for your information, every picture you've seen of the Milky Way actually is not really it, because we are in the galaxy. So it's kind of like if you're trying to take a picture of the outside of your house, but you're inside your house. Kind of hard to do. So the pictures that we're seeing are either another spiral galaxy kind of standing in, or an artist's rendition of our Milky Way galaxy. Our tier 2 question was, why does the Milky Way appear as a hazy band of light in the night sky? So in that case, if you do get out to a darker site, you're going to see a milky band across the sky. And the reason is it's just so many stars, and they're very, very distant. So our eye can't resolve them into individual pinpoints of light. So they kind of seem like this milky swath through the sky. And we're looking at just a portion of our Milky Way at that point. We're kind of looking towards, in this image, towards the galactic center. And with a camera, like you're seeing here on the right, you can see a lot more detail. So those are a couple of reasons why we can't see to our center of our Milky Way galaxy, and why our Milky Way galaxy looks like that milky appearance. And that's it. So I'm going to go ahead and turn this over to Zunan.
Well, thank you very much, Cheryl. That was a great explanation. Okay, so now it's time for us to take a look at some of the live chats. So we've got a couple of great questions. First one is from Rambo, 6-year-old, asking, where did all the galaxies come from?
That's a very good question, and I'll answer that one. When the universe first started in what we call a Big Bang, matter, after a little bit of time, was forming around in a circle, a giant, big, swirling mess of stuff. Gravity started to pull that material together, into stars, so where they would actually start nuclear explosions to burn brightly. But as stars started to glow together, they still had that rotation. So because of gravity, collections of stars gathered into the galaxies that we see. And meanwhile, stars are forming, exploding, forming new stars. Galaxies even collide together and rip each other apart or form new galaxies. In fact, in quite a long time, Andromeda will collide into our Milky Way galaxy, and we'll have a new one called Milkdromeda.
Well, cool. Thank you, Brian. And the next one, also from Rainbow, asking, okay, so this is a sort of related question. How do astronomers know how old galaxies are? And one example, I guess, is that we know some of the globular clusters are 12 billion years old, but how did astronomers determine the age?
Yes, another wonderful question, and I will answer that one too. So when we look at a star, we can actually divide the light that comes from that star into what's called the spectrum. You can think of that like a rainbow. And the spectrum actually tells us what kind of elements are in that actual star. Based on the brightness of the star, the kind of elements that are in, we can guess where it is in its life cycle, from when it first formed and started burning in a fusion reaction to where it's running out of the fuel and either starts burning through various elements, or I should say fusing them. It's not technically burning. But by looking at the spectrum, we can tell a lot about the age of the star. So then in a globular, they start to average out the age of each of those stars, and they start to build an idea of the age of that entire globular cluster.
Thank you very much, Brian.
Welcome.
That's a wonderful answer. Okay, moving on to the next one. We have Stephen Bowl asking, is M22 passing through the Milky Way between us and the galactic center? Is it going from a galactic north to south or the other way? Randy, you would like to take this?
Yeah, I guess so. It is going in front of the galactic center for us, but I don't know exactly which way it's going, north to south to north. I'd have to look that up. There is information that they do show which way it's moving, but I don't know offhand what that is. Sorry about that.
Well, that's completely fine. And we would probably encourage you to also, Google search that since we don't know everything, which is completely fine. Well, thank you, Randy. Next question is from Kayla D, asking, why don't we have a picture from the top down of the Milky Way? Cheryl, I think this is more related to what you were just talking about.
All right. Well, again, we can't, because we're not outside of our Milky Way, we're inside our Milky Way. So another way to think of it is, if you're a flea on a dog and you're trying to take a picture of the dog, you're not going to see the entire dog. You're just going to see some of the fur of the dog. So unless we're able to get up out of the galaxy, which we don't have that ability right now, we're not able to see the entire Milky Way. So we see a portion of that when we're looking, particularly in the summer months, towards the Sagittarius area. You see the galactic core area, which is nice and bright.
Great. Thank you, Cheryl. And one last question for this session from Addison Ivy Park, asking, would it be possible to travel outside of the Milky Way?
Oh, that would be wonderful to be able to fly up there and take a picture from outside our own galaxy. But at this time, we'd have to say, no, it's not really possible. The Milky Way is between 980 and 1,300 light years tall. So that's even traveling at the speed of light. It takes many, many lifetimes just for light to go from one side of the galaxy. And so we can't travel anywhere near that fast. So what we'll have to do is let the light come to us and then enjoy the views from right here safe on Earth.
Yeah, great. Thank you, Brian. Okay, so that concludes our chat room check-in at this point. And next, we are going to have our story time.
Yes, story time. And tonight's story is called The Center of It All. Thousands of years ago, almost everyone believed that the Earth was the center of the universe. Observers of the sky could clearly see that the sun, the moon, and the planets, and the stars all appeared to orbit around the Earth. This view of the universe is known as geocentric, the geocentric model. One of its biggest proponents was an Egyptian mathematician and astronomer by the name of Claudius Ptolemy. He believed that the universe was arranged in a complicated series of nested spheres, each moving independently of the others. The Earth, of course, would be at the center, and then each of the visible planets had their own sphere, as did the sun, the moon, and the stars. The geocentric model of the universe was almost universally accepted for more than 1,000 years.
In the year of 1514, a Polish astronomer and mathematician by the name of Nicholas Copernicus published a book in which he described a model of the universe where the sun was at the center instead of the Earth. This became known as the heliocentric model, and it took more than 100 years before it was generally accepted by the scientific and civil authorities. When Galileo first began using a telescope to observe the planets in 1610, he found irrefutable proof that the Earth was not the center of the universe. But even then, many people continued to believe in the geocentric model.
Now, the Earth and the planets do indeed orbit around the sun. As such, the sun can be considered the center of our solar system. However, it is not the center of the universe. In fact, the sun is not even the center of our own galaxy. On the contrary, the sun is just one ordinary star out of hundreds of billions of stars in the Milky Way. And most of those stars also have planets that orbit around them. So if you gaze into the steam coming off of the teapot that we talked about earlier, and that comprises the constellation Sagittarius, you will be looking into the direction of the center of the Milky Way galaxy, which is about 26,000 light years away. Our solar system revolves around the galactic center every 230 million years. And now we believe that there is a supermassive black hole residing at the center of the Milky Way. Clearly, the Earth is nowhere near being the center of anything. But maybe, just maybe, the Milky Way is the center of the universe.
Up until 1920, most astronomers believed that the Milky Way contained all the stars in the universe. If you recall the story presented at our last virtual Stargazing, the American astronomer Edwin Hubble proved that the Andromeda galaxy is outside of the Milky Way. And that finally settled the great debate in the 1920s. Not until then did astronomers realize that the Milky Way is just one of billions of galaxies scattered throughout the universe. As our understanding of the structure and size of the observable universe continued to grow, the idea of it having a center became meaningless. It may be hard to comprehend at first, but there is really no center of the universe. The expansion of the universe happens uniformly everywhere, almost like the stretched surface of an expanding balloon when you blow it up. The distance between the galaxies gets larger as the universe expands. From the Earth's point of view, the other galaxies appear to be moving away from us as if we were the center of the universe. However, the same would be observed if we were in any other galaxies. When everywhere seems to be the center, there is really no center. Our understanding of the Milky Way and the universe has progressed so much in the past several hundred years. The more we know, the more we realize that our Earth and the solar system are not special, and that there are countless worlds out there just like ours. I hope you enjoyed that story.
All right, so now we're going to go back outside with our telescopes. And this time, we're going to have a fancy professional telescope with Amanda, and she's going to show us what's known as M17. And that, of course, is in the constellation Sagittarius. As you can see here, the teapot and the steam, and way up above the teapot, that's another amazing nebula. So, Amanda, take it away.
Thank you, John. Okay, so let me share my screen first. Okay, so can you see that?
Yes.
Thumbs up. Okay, cool. So hi, everyone. My name is Amanda, and I'm a graduate student at UC Riverside studying very large galaxy clusters. But today we're going to be observing with a telescope called Stone Edge Observatory at the Stone Edge Observatory, which is located in Sonoma, California. I'm actually currently in Chicago right now, and I'm going to be remotely observing with this telescope, which is really awesome. It demonstrates the power of technology today. And actually, this dome or this observatory was specifically made to observe remotely with. It's kind of really small in there, and you can't really observe on site. The telescope itself, though, is pretty big. Its mirror is a 0.5 meter in diameter, which is pretty powerful. And today, the object that we will be looking at through a couple of different filters. So for some of you who have joined us before, this will be a refresher, but for everyone else, the Stone Edge Observatory actually has 7 different filters. And what filters are is just, they tell us about the different properties of the objects that we're looking at. So specifically today, we're going to be looking at a nebula, like John said, and we're going to be looking at it through the H-alpha filter, which is just a fancy name for a filter that shows us about the gas and the nebulosity of the object that you're looking at. A lot of the time that correlates to, or that corresponds to places where stars are being born or star forming regions. So we'll see some of that today. We'll also be looking through the oxygen 3 filter, which is again, just a fancy name to say that it is looking at the really high temperature part of the gas. So let me show you what the actual telescope looks like. So let me turn on the lights because it's dark in there right now. Okay, so here is the telescope. It is already pointed to the position of the sky that we care about. You can't really see much, but it looks pretty cool. And let's jump into observing now. And before we do that, let's turn the lights off because that's an important detail. So we'll be observing today with through a Slack interface called Ishel. We named it Ishel because it's the Mayan goddess of the moon, so we thought it was pretty appropriate. So let me send the command to actually observe this object, and then I'll tell a little bit about it. So the way we do it is we do \image. Let's do a 30-second exposure in the H-alpha filter. And remember, H-alpha is what's going to tell us about all of the nebulosity and the star forming regions in this object. So we're going to be looking at something called the Omega Nebula, which is otherwise known as the Swan Nebula, otherwise known as the Checkmark Nebula. Astronomers like to name things as they look, which kind of makes sense. It was discovered in 1745 by a Swiss astronomer by the name of Jean-Philippe Loy de Chaux, and it's been observed multiple times later to try to really understand the structure. It's actually 15 light years in diameter. So if you're on one side of the nebula and you're texting your alien friend on the other side of the nebula, it will take 15 years to send that text message. And it can be seen with a pair of binoculars in pretty dark skies. Okay, so just in time, we have our nebula image come back. So this is what it looks like with the H alpha filter. And you can kind of, to me, it kind of looks like a swan, I think is the best representation of it. And so there's a lot of nebulosity here. And the reason for that is it's considered to be one of the brightest and most massive star forming regions of our galaxy. And it's actually one of our galaxy's youngest star clusters at only around 1 million years old. That sounds like a lot, but it's actually pretty young by comparison. Orion, for example, is 3 million years old, and our planet Earth is over 4 billion years old. So it's very, very young. And scientists think it hasn't even had its first supernova yet. So let me actually send the command for the other filter. So scientists think that it hasn't even had its first supernova yet, which is pretty incredible because it makes it a great laboratory for scientists to study how really big and massive stars interact with their environment before a supernova comes and sort of explodes and messes it all up. So it's a really great laboratory in one of the youngest clusters of our galaxy. So yeah, you can see that where there's a lot of gas, that's where stars are being formed or being born, actually. So it's a really big stellar nursery. There's also a lot of dust, so it's kind of hard to see the stars inside. But number one, the radiation from the stars is able to break through and erode some of the dust. So you can see some highlights over here. And the dust is also being heated up, so you can see some of it glowing as well. So our O3 image came back, and you can see that it gives you a lot less detail than the last one. Let me show you a better image that I took earlier. It could be that this one, that it just clouded over. So let me just show you that. 2 seconds. I just want to show you guys the difference. It's important. Well, maybe we'll forget about it. Okay, it's okay. So you can see how in the O3 image, there's a lot less detail here, and that's because the hottest part of the nebula is actually right in the center. So if you take this image on a clear day and you take it for a long time, you can actually see, and you stack it, you can see something that looks like this. Here's that Swan Nebula again for reference. This is a 75-minute long exposure. And if you have the Hubble Space Telescope and you happen to be able to observe with it, you can zoom really far in. That's zooming in this region over here. You can zoom really far in and see some of that gas and that stellar nursery over here. So I hope you enjoyed that. That's it for me. Take it away, John or Zinon.
All right, now, every month when we do these programs, I like to do what we call naked eye gems. If you don't have a telescope, you can go outside and what kind of cool stuff can you find? And as again, we're focusing on Sagittarius here. And unfortunately, Sagittarius is really pretty low in the southern sky. So if you're up around Canada or kind of more northern latitudes, it's going to be hard to see Sagittarius. But if you're down here like in Southern California, like I am, it's pretty high in the sky, so it's pretty easy to find. And again, there's the teapot, right? We've talked about that. So the teapot right here is pretty easy to find by now, and as I think it was Randy mentioned, once you find the Scorpius, the scorpion over here, which is pretty easy to find, you just look over to the left, or more towards the east, and you'll find Sagittarius, right? Now the trick here, I'm going to cheat a little bit. So instead of a regular naked eye objects, which the Milky Way on a dark night, you can go and look at the steam coming out of the teapot. If you're in a pretty dark location, right, you can do that, and it's beautiful. But let's say you're not necessarily in a very dark location, but you have a pair of binoculars. So something, hold on a second. I'm not even showing my camera. I'm sorry. I want you to be able to see this. I'm going to stop sharing, open up my camera, share again. So here we are with the constellation of Sagittarius. And if we are looking around, as I think by now you probably have an idea, is that all around in the steam here that's coming out of the teapot, there's all kinds of beautiful things you can see, especially if you have binoculars. So a pair of 7 by 50 binoculars, I'll show you these in a minute, you can get for like $35 at Amazon. And you take those outside and just spend a night browsing around in Sagittarius area, and there's just amazing things to be seen, all kinds of stuff. And for example, let's look over here at one of the Messier objects there, and let's say we'll look at M18, which is an open cluster of stars. And if we zoom in on it, keep zooming as if we had binoculars, you would see this beautiful cluster of stars. Or we could look at another possibility, which would be, let's say M23. And there you can see, again, it's highlighted up here in the steam. And if we zoom in, get closer, as if you put a pair of binoculars up to your face, you see there's another beautiful cluster of stars. And these often remind me as if you had some diamonds and sprinkled them loosely on a black velvet cloth, this is what you'd see. They're just beautiful little constellations that are not constellations, clusters of stars that you don't quite have naked eye. I mean, some of them with people with really good eyes, if you're young, you're in really dark skies, you can get a sense of some of these things with your naked eye. But if you can, spend 35 bucks, get yourself a pair of 7 by 50 binoculars on Amazon and go outside with those before, you know, Sagittarius disappears in the winter sky. And you'll see all kinds of beautiful things. So with that, let's go and ask some questions for you guys to start thinking again.
Yes, John. And now we have our trivia question number 2 for tonight. And the first here is, do you think the constellation Sagittarius is physically located at the galactic center, which means the center of the Milky Way? That is, again, a yes/no question, and you can put your thoughts into the chat. And if you want to challenge yourself a little bit again, here's another question. What kind of celestial objects do you think we can find at the galactic center? So everything that you think might be related that we could observe very close to the galactic center, you could put it in the chat, and later Yongda will reveal the answers for us.
All right, terrific. So we're going to go outside one more time with our telescopes. And again, aiming the telescopes up at Sagittarius, we're going to find yet another beautiful nebula. And Manny will take us there. Manny? Do we have Manny?
So Manny was reconnecting his internet. You're muted, Manny.
Okay, I'm now unmuted. With apologies to everyone, my internet literally just went 100% down. I had to run back to the house. And yeah, so it's been exciting. So here we go. So this is going to be a little more rough and ready perhaps than I had intended. What you're looking at there on the screen is me actually with my telescope. And I'm going to go back and show you. Let's go here. Okay, so with a little bit of drama, my name is Manny Lyons, and I am coming to you live from my observatory here in lovely Mariposa, California. We're just about an hour west of Yosemite National Park. I am a retired former engineer with the space business from the Boeing company. And you might have heard lately in the news that there's a new spacecraft getting ready to launch called Starliner. Well, one of my former jobs was leading the team of engineers that developed the sensor system that will allow that Starliner spacecraft to dock with the International Space Station. So I'm very excited to see a successful launch and docking very soon. Anyhow, I have been a member of the Riverside Astronomical Society for several years and an amateur astronomer now for over 30 years. So this is the telescope and camera that I'm going to be showing you to take you to the glorious Eagle Nebula. The telescope is 11 inches in diameter, and it's a little bit odd because the entire camera mounts on the front of the telescope, which you can't really see right now because it's pointed to the south toward Sagittarius. The mirror is at the back of the telescope here, but back right here. Sorry, you really can't look through this telescope because of the way the camera mounts on the front. It's an 11 megapixel camera. It's cooled about to 50 degrees below ambient temperature, so very chilly, and that reduces the noise in the picture. And then this mount right here tracks the stars and allows us to have very long exposure. So without further ado, let's go on to our target here. And so I think you've seen a chart like this several times today. Randy showed you M22, Brian showed you the Trifid M20, and Amanda showed you the Omega Nebula. So all of those three objects are in the constellation Sagittarius. My object, you see the little dotted line here? Well, that's the border. You really can't see that. There is no dotted line in space. But this is the constellation of Serpens, the serpent or the snake. And we're just across the border. So we're very close to Amanda's object. But I'm going to show you M16, the Eagle Nebula. So coming right at you. So this is a live view from my telescope, the one that you just saw behind me. This is the Eagle Nebula. And it is, just a second, let me go back here. The Eagle, these are 15-second exposures. So one after another, the telescope is keeping its shutter open for 15 seconds. This nebula here, and you can see sort of a double eagle in my view. So there's the head and some wings, and then there's a little eagle in the middle too. So this nebula was discovered back in 1745 by the same astronomer who discovered the Swan Nebula, Jean-Philippe Loy de Chasseau. And it was published as the 16th object in Charles Messier's catalog of things that are not comets. So the Eagle is made up of an open star cluster, which you can see right here. And believe it or not, that star cluster is estimated in having over 8,000 members. And these regions of gas here are actively forming new stars. The nebula is about 7,000 light years away from us, and it's within our Milky Way galaxy. That's about 70 by 55 light years across, so quite large. And Amanda stole my joke about texting across the nebula, so I will spare you. I will spare you that. But
Very many.
in any event, another thing I find interesting is that I like this little open star cluster here as well, and I could not find this on star chart. So someone perhaps that has a very deep star chart might be able to find that. But this is the Milky Way galaxy, so just look at the number of stars here because we are looking toward the center of our galaxy. Now, if we were to take a long exposure, which I have done just about a year ago, here is an image that I took back in August of last year. This was taken with the same telescope and the same camera that I'm using tonight. This is a combination of 10 separate 5-minute exposures. So the equivalent of leaving your camera shutter open for about 50 minutes. And the final image here I processed with some software. I used actually what was called Deep Sky Stacker and Photoshop in this to bring out the faint details here. And then note the central dusty star forming region here. We're going to talk about that in a moment. So with that, let's fly into the Eagle Nebula. So here's Sagittarius. And hopefully you can see this. Here are some nice images. I believe that is the Lagoon Nebula here. And here comes the Eagle. So this should look similar to what we just saw, but we're going to keep zooming. And in we go to the very center of the nebula, to these amazing pillars. And so this structure here has been, I think, aptly called the pillars of creation. These are towers of cosmic dust and gas at the heart of the nebula, and it's been named the pillars of creation. It is one of the most famous Hubble Space Telescope images that you will see, and it is an active star forming region. The pillars are about 4 to 5 light years across. And so although they're a small part of the nebula, they are truly huge. This is also, you heard earlier about false color images. This is also a false color image. This is oxygen is represented here by blue, and red is the light of sulfur, and the green is nitrogen and hydrogen. So if you lived on a planet somewhere here in these pillars, and these are called eggs, as Brian told you before, evaporating gas globules. These globules are being worn off by ultraviolet light from a nearby star cluster. So you would need to wear a lot of sunscreen if you lived on a new planet there. So the winds of the winds here are slowly wearing away the towers. So the generations, hundreds, thousands of years from now, we'll see new stars and planets in these areas. And I will take it back to you, John.
Thank you, Manny. Boy, those are beautiful pictures. Okay, so you've all had a chance to think over what kind of answers can you come up with from our last set of trivia questions. So Youngda will tell us the answer. Take it away.
Okay, thank you, John. So hi, everyone. I can see most of you got the correct answer in the chat. For the tier 1 question, the constellation Sagittarius is not physically located at the galactic center. So in fact, our sun is about 26,000 light years away from the Milky Way center. Well, the stars that make up the constellation are within 400 light years from the sun. So these stars are actually our neighbors and are far away from the galactic center. Otherwise, they'd be too faint to form the constellation. As for the tier 2 question, near the galactic center, there are stars and a supermassive black hole as shown in this image. And this SGRA star points to the location of the supermassive black hole. By measuring the orbits and the speeds of the stars orbiting the black hole very closely, we can infer the mass of the black hole of about 4 million solar masses, which is very dense. And the horizon, and the event horizon, or the size of the black hole, is about 14 million miles in diameter. But since it's too far away from us and difficult to observe, so far we don't have a direct image of the black hole near zone. The simulation tells us the shadow of the black hole may look something like this, just like a donut. However, we still don't understand the black hole very well today. Here's just an artist's illustration of a supermassive black hole surrounded by an accretion disk and emitting a realistic jet. Let's then zoom out a little bit. In the region not so close to the central supermassive black hole, there's also a star cluster, which is called the Nuclear Star Cluster, or NSC for short. NSCs are very dense and are on average 40 times brighter than globular clusters. Also, unlike the globular clusters, the nuclear star cluster contains a mix of both very old and very young stars. If we zoom out again, we will have the galactic bar or the bulge as mentioned by someone in the chat, but that will be a more macro structure. Okay, now we know a little bit more about the objects near the galactic center. Thank you.
Thanks, Youngda. That was great. Okay, so we'll go back to our chat room and see what kind of questions and comments people have been giving us.
We have actually received a lot of great questions, and I am going to start with a question from Kayla D asking, where is the Earth in its lifespan? Will there ever be another planet habitable? So that is a great question because okay, so we typically talk about the sun being a middle-aged star exactly in the middle of its lifespan. And I would say, our Earth's lifespan is sort of depending on where the sun is, because in about 5 billion years, the sun is going to run out of fuel at its core, and it will puff up a lot, more than 200 times the current size of the sun. And at that point, it will engulf Mercury, Venus, Earth, us too. So at that point, we cannot really survive. And that I would consider as the end of the life of Earth. And of course, when that happens, the habitable planets, it all depends on the central star. So if the sun is getting bigger and emitting more light, then it's automatically pushing out the habitable zone. So by that time, actually Mars would be in the habitable zone, but not for very long, because the sun will evolve very fast through this stage and eventually eject the outer envelope and become a white dwarf. So yeah, being a habitable planet is a relatively, it's a relative sense. Okay, so I hope that answers your question. And next question, I believe, again, from Kayla is for Amanda. So if Amanda can use the telescope from Chicago, how does it exactly work over the computer?
Yeah, so that's a great question. Again, power of technology. Basically, there is a computer that is located on site inside the observatory that is connected to the internet. So in the same way that you're able to see us over Zoom, we're able to communicate with this telescope. The Slack interface is just something that was programmed to communicate with the computer at the observatory so that we can talk to it and ask it to take pictures for us. I also wanted to mention that if the telescope is primarily used, at least Stone Age Observatory is primarily used for outreach. So if you are a student or a teacher or an educator, please reach out to me if you're interested in getting your students to observe with the telescope. And I think Jinan will list my information, I guess.
Great, yeah. So we can certainly send that information in the chat. So now moving on to the next question, which is sort of related to what I just talked about. So this one was from Ryan P asking, wouldn't Earth technically be around forever if it becomes inhabitable, even if it becomes inhabitable? And as I described earlier, I mean, if we were not talking about the sun really puffing up and directly eating Earth, yes, it would just be there forever. But currently, we do not think the Earth would actually survive being inside of a star. So it should just like break into like different smaller pieces of rocks, maybe. So that would definitely be our doomsday, but we don't have to worry about it. It's going to be in 5 billion years. So still quite some time. Okay, next question is, okay, so from Rosa Lopez asking, oh, I have a technical question about telescopes. How difficult it is to see objects clearly when you wear glasses. I have the hardest time seeing things with my glasses on. I'm blind as a bat.
Yes, I'll answer that question. I know what you mean. Without my glasses, I'm in trouble because I need glasses to find my glasses. But when you have glasses that are a proper prescription, you should be able to see relatively easy through a telescope. It all boils down to the eyepiece, which is what we actually look through. Now, something that can make it easier for you to observe is using an eyepiece that has what's called a good eye relief. that describes how far you put your eye away from the eyepiece. The farther the better when it comes to glasses. That way you don't have to bump right up against it. Something to keep in mind, if you have simple nearsight or farsightedness, you could actually take your glasses off and focus the telescope. If it's your own, ask permission if it's someone else's at a public event or something. But anyways, you could focus the image for your eyes in a unique way. However, if you have astigmatism, telescope can't correct for that. So you're better off keeping your glasses on. But definitely observe all you can. Just keep those glasses handy.
Great, thank you, Brian. And I believe Randy just had some new information for Rainbow's question earlier. Randy, would you like to, just quickly
Sure.
say that?
This is for Rambo asked the question, which way M22 was moving. I did some quick looking. I didn't find exactly the direction, north or south, but I did find that it is moving away from us at about 149 kilometers per second, or in other words, about 93 miles per second. So if you want to catch up to it, you got to get moving.
Thank you, Randy. Okay, so final question from Stephen Boll. Wasn't there a hypothesis that proposes that Sagittarius A star, which is the supermassive black hole, is not a supermassive black hole, but a dense concentration of dark matter, or maybe something else unknown?
So yes, I'll take that one too. Good question. And yes, there were some recent papers. I found an article as recent as June of this year, where scientists hypothesized that Sagittarius A may not be a supermassive black hole, but fermionic dark matter. Now, sometimes I wonder if scientists they try to float whatever ideas they can to publish a paper, but that's a different conversation. What happened is they were observing a cloud of gas that seemed to come dangerously close and was affected by the gravity, and they started to hypothesize what amount of gravitational pull would be needed to actually cause that kind of attraction. So there is no proof for the being dark matter versus a black hole, but the research continues.
Thank you, Brian. And adding to that, I would say, there are all different kinds of hypotheses people could propose, right? But which one is more popular or more convincing, that would depend on the kind of data that we use. In this case, to study is the speed and motion, the orbits of the stars that are really close by. So what Yunda has shown you is actually over 20 years of data collected by a group at UCLA. And for that, they have actually measured the size of the central region to be really, really small, with 4 million solar masses. So it would be extremely hard for us, at least for now, to imagine, what it could possibly be other than a supermassive black hole. But it's a active area of research, so we shall see. And John, I guess it's now time to wrap up.
Time to wrap it up. Yep. So let me talk a little bit about my club, the Riverside Astronomical Society. We are an amateur astronomy group, and we are one of hundreds, if not thousands, of astronomy clubs scattered across the United States, all over the world. So if you happen to live in the Southern California area, particularly around Riverside, I encourage you to join us. At the very least, start attending some club activities, and maybe become a member. If you're not in the Riverside area, Google it, and you might find there's an astronomy club right next to you that you didn't know was there. But it's a great way to learn about astronomy, great way to look through telescopes that you don't have to buy any, you just use the other people's telescopes. So our address on the web is rivastro.org, rivastro.org, and check us out.
Thank you, John. And now I will also promote UCR Astronomy a little bit. And as some of you might have already been aware, we have a Facebook page. If you simply just search UC Riverside Astronomy or Astro UCR, this is the page that you are going to see. So whenever we have an event, we would post it here. We would also have, any kind of updates that we have. And the next event is actually a public lecture on the 26th of August, so talking about life beyond the solar system. So you can simply just follow or like us here. Or another way to keep in touch is if you search UC Riverside Astronomy Community Outreach, and I will also be posting this link in the chat. Basically, this is where we post all the scheduled events. So as soon as we schedule an event, it will pop up here and you can basically explore the event a little bit further to see whether that is of interest to you. So of course, one last way is to sign up on our email list, which you will get a chance to once you receive the survey. That will be sent out tomorrow. So I guess that's what I wanted to say. And maybe now it's time for raffle, right?
Wait.
Oh, okay, yeah.
Actually, and Sinan reminded me, these are things I should have said about the Riverside Astronomical Society, is that we do in-person outreach at schools, scout troops, things like that. We haven't done them for the last year and a half or so because of the COVID, but now we're hoping to start up again. So we actually have an event scheduled for the public at the shops at Dos Lagos, which is a shopping mall in Corona, California, on August 14th, Saturday night, August 14th. So mark your calendars. If you're somewhere in the Riverside area, come join us. We'll be able to see Jupiter, Saturn, the moon. It'd be pretty cool. And again, like if you go to our website, there is a calendar on the webpage that shows when and where we're going to be doing different outreach activities.
Thank you, John. Oh, sorry, I cut you off.
Let me just share my little bit about the resources for people who are interested in astronomy. There is an excellent book for children called The Child's Introduction to the Night Sky, written by Michael Driscoll. And it's a terrific book for maybe elementary age kids, early middle school. For young adults and adults, there's a great book called Night Watch, which is a terrific introduction to the hobby and science of astronomy. A couple of magazines you can go pick up at Barnes & Noble if you don't want to subscribe, that keep you up to date on what's the latest going on in astronomy. And one of those is called Astronomy Magazine. The other is Sky and Telescope. Skymaps.com, a great website you can go to every month and download a free star map to see what's in the sky that month, because things change from month to month up in the sky. Sky Safari is a terrific app you can use for your phone or your tablet. Stellarium is what you've been seeing tonight in terms of when I've been modeling the sky and such. That's a free download for your computer. You can use your Chromebook and go to the website and use it. There's also apps for your phone and such. So some great resources for you to follow up on to nurture your love of astronomy.
Thanks, John. And for getting those links, you could also simply just click the description of this YouTube video. So I have included some of the important links there too. So you could directly just save those. And now it's our raffle time. I have just posted the raffle link to the live chat. So all you need to do is just to put your name and the email address. Yes, love that book. To the form, and if you win, we will contact you. So for this specific one, we are going to raffle off 4 books, and wish you luck. Okay, so I guess the final thoughts or final comment that I'm going to give is many people have asked me about, how are we going to, keep doing outreach moving forward since, now the country is or has been slowly opening up. So UCR Astronomy will take a relatively cautious approach. And for now, and until the rest of the year, we are going to still have all virtual outreach events just online, like what we have been doing in the past year or so. And if the COVID situation doesn't get worse and, it's safe for us, especially to host something on campus, large scale, then we're going to slowly transition back to in-person outreach events. But I know we're also having a worldwide audience here, and we certainly would love to provide you with something to stay connected. So even though after that we completely, open up and get back to normal, we will still provide virtual outreach events just like this, maybe with reduced frequency, but there will definitely be opportunities for us to connect again. So for the near future, we are going to have quarterly stargazing. As John mentioned, the RIS outreach crew will have a shifted priority to in-person outreach. So we're gonna, instead of doing monthly virtual stargazing, we will be doing quarterly for the fall, and we will keep everyone updated regarding what our plans are, as things are still, constantly changing at this point. John, you have anything to say about that?
No, other than the main thing, as Sinan just mentioned, our goal with the Riverside Astronomical Society outreach program is to meet with people face to face and actually have people look through a telescope and have the photons from Saturn actually hit them in the eye. So to the extent that the COVID precautions and such allow us to do that, that's going to be our focus for forever. But if things wind up with the COVID's locking things down again and making it so it's not safe to be with people, then we will continue virtual outreach, gladly.
Yeah, so regardless, UCR Astronomy will still be providing various virtual outreach programs. Even aside from the stargazing program, we still have the public lectures, and we will also, we are more than willing to create new programs if you prefer. So I will be putting that also as a question in the survey form that you will receive tomorrow. So thank you everyone for joining us tonight. I hope you enjoyed today's show and had a great time. So as mentioned earlier, we would really, really appreciate your feedback on our performance today. And if you could just kindly, use 2 or 3 minutes to fill out the survey I send out tomorrow, that would be greatly, greatly appreciated. Also, it's going to be anonymous, so we'll only be looking at the statistical results. Well, with that, I think that's the end of our show this time. So I hope everyone have a great night. Let me just turn the gallery view back on so we have a chance to say everyone. So say goodbye to everyone.
Good night,
Until next
everybody.
time. Bye. See you later.
Bye, everyone.